Greetings. Welcome to our lecture series on mechanics of solid. In this prerequisite session, we will be discussing about the types of coordinates. In engineering mechanics and mechanics of material, we generally came across the Cartesian coordinate or rectangular coordinate system. The second one is the cylindrical coordinates, or it is also known as polar coordinates, and spherical coordinates. Let us understand this concept of coordinate system, which begins with the identification of origin. From this origin, if we extend a numeric line along horizontal plane showing the negative and positive values, we generally refer this as a ordinate axis. In one dimension system, we call it as a x-axis. Similarly, we can have the distribution of numerical scale about vertical axis, and this will called as a y-axis, and this x and y plane will be called as a 2D plane. This 2D plane helps us to locate the coordinates. Also, it helps us to define the system in terms of quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. These quadrants define the location of the point with reference to its numeric value. If we talk about the three-dimensional system, the three-dimensional system x, y, z are the orthogonal axes to each other, perpendicular to each other. If I want to locate a point P within this coordinate system, which is located at a radial distance r from origin, then the P will be having ordinates x, y, z, where x, y, z are the variables measured with reference to respective rectangular axes. In addition, if I am going to consider the curvature of the system here, and I am going to have a location of the point with reference to the circumferential axis with reference to its radial distance from the origin, considering z-axis as a we can say is a linear axis. So to locate the point P, we have to write the ordinates which will be representing the distance with reference to origin r, and the inclination in the plane which is measured from either axis. For example, here I have taken as a theta. Theta is nothing but angle of the line or the point with reference to the x-axis here. So theta will be taken, this rotation will be taken as a one of the ordinates, and z is the vertical intercept of this particular point, which we have considered as a moving linear. So in your cylindrical coordinate system, we are going to represent the position of point with the variables r, theta, and z. If I consider the point is being at an inclination with both the axes, like the horizontal plane as well as vertical plane. So I will introduce here the ordinate system, which includes the radial distance r, the angle of the twist theta with reference to the plane, and angle of the line or this point with reference to the vertical plane. So here the coordinates will be represented by r, theta, and psi. So we call this type of system as a spherical system. So for more updates, such important more update, I will come with another contents. Till then, goodbye. Stay safe.